Hello everyone, this is Siddharth Singh. This is REC assignment and the questions allotted to me are from 9.7 to 9.13. It's from the chapter 9 of Charles K. Alexander called Fundamentals of Electrical Circuits. So the first question is 9.7. The question is if f in the function of phi is equal to cos phi plus j sin phi, show that f phi equal to e to the power j phi. So the solution for this question is if the given equation f phi is equal to cos phi plus j sin phi is differentiated with respect to phi, we would get minus sin phi, which is the differentiation of cos phi, plus j cos phi, which is the differentiation of j sin phi. So from this we can write that taking j common, and we could write in the bracket like cos phi plus j sin phi is equal to, yeah, it becomes the first question. So equal to j f phi. Now df by f equal to j d phi. We bring the common variables to one side. Now integrating both sides. So the equation turns into ln f equals to j phi plus ln a. So f equals to a into e to the power j phi, which is also equal to cos phi plus j sin phi. Now putting the value of phi 0, we would get that a equals to 1. So that makes our equation like f phi is equal to e to the power j phi, which we had to prove, equals to cos phi plus j sin phi. Moving on to the next question, question 9.8. Calculate these complex numbers and express your results in rectangular form. A part 60 with a phase angle of 45 degree divided by 7.5 minus J10 plus J2. B part is 32 with a phase angle of minus 20 degrees divided by 4 plus 2J multiplied by 6.8J plus 20 divided by minus 10 plus 24J. The C part is 20 plus 16 with a phase angle of minus 50 degrees and multiplied by 5 plus 12J. So the solution of this question 9.8 is for the A part, which is 60 phase angle of 45 degree divided by 7.5 minus 10J plus J2. So the solution for this part is that we change the denominator of the first brackets, that is 7.5 minus 10J, into its phase form, that is 12.5 with a phase angle of minus 53.13 degrees. So the equation turns into 60 phase angle of 45 degrees divided by 12.5 phase angle of minus 53.13 degrees plus J2. So solving this division, we get 3 phase angle of 98.13 degrees plus J2. Now changing this phase form into the rectangular form, we have the equation turn into minus 0.6788 plus 4.7517J plus J2. So our final answer becomes minus 0.678 plus 6.75J. For the B part, the question says 32 with a phase angle of minus 20 degree divided by 4 plus 2J multiplied by 6.8J plus 20 divided by minus 10 plus 24J. So we solve the denominator of the first bracket and it comes out to be 44.78 with a phase angle of minus 26.57 degrees. Then we replace this value and the equation becomes 32 phase angle minus 20 degrees divided by 44.78 phase angle 26.57 degrees plus minus 10 minus J24 into 10 divided by 100 plus 576. This came from by multiplying the conjugate of minus 10 plus J24 in both the numerator as well as the denominator. So we received this equation. Then solving the first and the second brackets and changing them into the rectangular form, we get 0.709 plus J 0.08169 minus 0.147 minus J 0.355. So normal subtraction and addition, we get 0.562 minus J 0.2733. This is the answer for the B part. Moving on to the C part, the last part, it says like 20 plus 16 with a phase angle of minus 50 degree multiplied by 13 with a phase angle of 67.38 degrees. So solving the multiplication, we get 20 plus 208 with a phase angle of 17.38 degrees. Changing this into the rectangular form, we get 20 plus 198.50 minus 62.13J, and adding the 2, we get 218.50 minus 62.13J. This is the answer for all the three parts. Moving on to the next question, question 9.9. Evaluate the following complex numbers and leave your result in polar form. So 5 with a phase angle of 30 degrees multiplied by 6.8J plus 3 phase angle of 60 degree divided by 2 plus J. And the B part is 10 phase angle of 60 degree multiplied by 35 phase angle of minus 50 degrees divided by 2 plus 6J minus 5 plus J. So this is same as the earlier question, same type. So the solution for this question, the A part, is, as the question says, 5 phase angle 30 degrees multiplied by 6.8J plus 0.717 plus 0.473J, changing the question into rectangular form of the of the multiplier. So the equation becomes 5 phase angle of 30 degrees 6.7 multiplied by 6.717 minus 7.527J. Then changing the multiplier into the polar form, we get 5 phase angle of 30 degrees multiplied by 10.088 phase angle of minus 48.23 degrees. Multiplying these two, we get 50.44 with a phase angle of minus 18.23 degrees. This is a polar form and this is the final answer for the A part. Moving on to the B part, we have 10 with a phase angle of 60 degrees multiplied by 35 phase angle of minus 50 degrees divided by minus 3 plus J5. Solving the denominator and changing it into the polar form, we get 10 phase angle of 60 degrees multiplied by 35 phase angle of minus 50 degrees divided by 5.83 phase angle of 120.96 degrees. Solving this by multiplying the numerators and then dividing the given multiplication by 5.83 phase angle of 120.96, we get the final answer in polar form as 60.02 with a phase angle of minus 110.96 degrees. Moving on to the next question, question 9.10. We have, it's given Z1 equals to 6.8J, Z2 10 with a phase angle of minus 30 degrees, and Z3 is equal to 8 e to the power minus J120. So we have to find A part Z1 plus Z2 plus Z3, and B part is Z1 into Z2 divided by Z3. Okay, so the solution for this 9.10 is Z1 is already given in a rectangular form, that is 6.8J. We change Z2 from polar to rectangular form and it comes out to be 8.66 minus 5J. We change the Z3 in from Euler's form to rectangular form, it comes out to be minus 4 minus 6.93J. Now for the A part, Z1 plus Z2 plus Z3, we simply add the three given equations and we get the answer to be 10.66 minus 19.93J. And for the B part, Z1 multiplied by Z2 divided by Z3, it's normal multiplication and division, we get the answer to be 9.999 plus 7.499J. Quite simple question. We move on to the next 9.11. The question is, find the phasors corresponding to the following signals. A part, V in the function of time equals to 21 cos 40 minus 15 degree volts. Then B part is I in the function of time equals to minus 8 sine 10t plus 70 degrees in milliamperes. Then V, same in the time function, is 120 sine 10t minus 50 degree volts. And D part, the last part, is I in the function of time equals to minus 60 cos 30t plus 10 degree milliampere. So the solution for this question 9.11 is the A part. We change the given equation into its polar form, and it comes out to be 21 with a phase angle of minus 15 degree. We change it by taking the magnitude of that given given the cos function, the magnitude, and getting the angle from the given function only. Then the B part is I in the function of time equals 8 sine 10t plus 70 degree plus 180 degree. Because we have to change it in the cos form, we subtract 90 degrees from it. So we get 8 cos 10t plus 7 degree plus 180 degree minus 90 degree. That comes out to be 8 cos 10t plus 160 degrees. Now changing this into the polar form, we get I equals to 8 with a phase angle of 160 degrees milliamperes. Now moving on to the C part, Vt equals to 120 sine 10t minus 50 degrees. 120, changing into the cos form, it becomes 120 cos 10t minus 50 degree minus 90 degrees. And then this changing into phasor form, sorry, becomes 120 with a phase angle of minus 140 degrees. Now the last part, D part, is I in the function of time equals minus 60 cos 30t plus 10 degrees. Changing the equation to 60 cos 30t plus 10 degree plus 180 degree, which replaces the negative sign outside. So we get this equation to turn into 60 cos 30t plus 190 degrees. From that we can see that I equals to, in phasor form, it's 60 with a phase angle of 190 degree milliamperes. Moving on to the next question, 9.12. Let x equal to 4 with a phase angle of 40 degree and y equal to 20 with a phase angle of minus 30 degrees. Evaluate the following quantities and express your results in polar form. Part A, x plus y multiplied by x conjugate. Part B, x minus y conjugate. Part C, x plus y divided by x. So moving to the solution of this question, 9.12. A part is x plus y multiplied by x conjugate. It is 3.06 plus j 2.57, changing it from polar to rectangular form, and same with y, changing it from polar to rectangular form. We get 17.32 minus 10j multiplied by conjugate of x, that is 8 with a phase angle of minus 40 degrees. Then adding the first bracket, the part in the first bracket, we get 20.38 minus 7.43j multiplied by 8 phase angle of minus 40 degrees. Changing the first bracket into polar form again, we get 21.69 with phase angle of 19.79 multiplied by 8 with a phase angle of minus 40 degrees. Multiplying these two, we get 173.52 with a phase angle of minus 20.21. So changing this polar form into rectangular form and getting the answer, we get answer to come out to be 162.63 minus 59.94j. Moving on to the second part, B part, is x minus y conjugate. We replace the values of x and y, 3.06 plus j 2.57 minus 17.32 minus 10j conjugate, whole conjugate. Then adding these two and taking the conjugate, we get minus 14.26 minus 7.43j. Changing this into the polar form, we get 16.079 with a phase angle of 27.52. The last part, C part, is x plus y divided by x. So So we already calculated the value of x plus y in polar form, so we just write it down: 21.69 with a phase angle of 19.79 divided by 4 with a phase angle of 40 degrees. Solving this division, we get 5.422 with a phase angle of minus 20.21 degrees. Changing this into the rectangular form, we get 1.4275 minus 1.1746J. Moving on to the last question of my part is 9.13, and the question is evaluate the following complex numbers. A part 2 plus J3 divided by 1 minus J6 bracket close plus bracket open 7 minus J8 divided by minus 5 plus J11 bracket close. B part bracket open 5 with a phase angle of 10 degrees bracket close multiplied by 10 bracket okay, bracket is already open, so multiply by 10 with a phase angle of minus 40 degrees bracket close, divide the whole division by two polars, that is 4 with a phase angle of minus 80 degrees and multiplied by minus 6 with a phase angle of 50 degrees. And the last part is the determinant form. We have to solve this determinant, that is 2 plus j3 minus j2 minus j2 8 minus j5. In the form you can see it is in, we have to solve this. So the solution for 9.13 for the A part is solving the parts and changing it into rectangular form. We get minus 0.4324 plus j 0.4054 plus, solving the next part also, minus 0.8425 minus j 0.2534. Adding them, we get the answer to come out to be minus 1.2749 plus j 0.1520. The B part, we solve the two brackets in the numerator and denominator. We get it to be 50 with a phase angle of minus 30 degrees and 24 with a phase angle of 150 degrees. Solving these two, the answer comes out to be minus 2.0833. So that's pretty much the answer. And then C part, solving the determinant, we get 2 plus j3 multiplied by 8 minus j5 minus bracket open minus 4 bracket close, normal multiplication and addition. We get the answer to be 35 plus j14. That's pretty much it.